Hello everyone, we are Triple T plus N, and today we will present our mini project for the Introduction to Algorithm course. Our topic is budget tracking, a simple tool that helps people understand and manage their daily expenses using algorithms. These are our team members. My name is Pasutali, and the rest will introduce themselves later. In everyday life, many students and working people spend money without tracking it. By the end of the week or month, it's hard to answer questions like, where did my money go? Which category do I spend the most on? Or how much can I actually save? And that's the main problem we want to solve. For example, sometimes at the end of the month, we barely have enough money to eat. Small expenses like buying coffee every day might not feel much, but they can add up to more than 1,000 baht or even $1,000 a month. A recent survey found that 98% of people agree that budgeting helps them reach their financial goals. So we want to design something practical that encourages better money habits. And the main concept of our project is to show how algorithms can be applied to solve a real-life problem. Managing personal expenses, we treat every expense as data and then use basic algorithms to organize and analyze it, like sorting, searching, and grouping. And here is the overall process. We start by inputting expenses, then choose what operation we want, like insert, delete, search, or sort, and finally display the organized result. It's a small but effective example of how an algorithm process can help manage data in real life. And there are 5 main algorithms we are using. The first one, add new expenses. The second one, delete expense by index. Next is sorting expenses, and the next one is search expenses. The last one is show totals by categories. Now I would like to show the code on our Colab and see how our code works. You can see the sample inputs right here, expenses, and I would like to talk deeper about the first option, which is adding expenses. So in this part, I will explain how our app inserts a new expense into the datasets and keep inputs valid and maintain a sorted view without using any library sort. Each expense is a dictionary with 4 fields: date, category, item, and amount. All expenses live in a Python list called expense. That is our primary data structure. When I choose add new expense, the function add expense collect 4 inputs. The first one is prompt date, loops until the user give a valid year, month, and date. The second one is prompt category. Show a fixed list of category. Any invalid choices become other. And the next one is item is a free text string. If blank, we will store no name. And the last one is prompt float loops. It will get a positive numeric amount. And for this front load validation, so we never insert a bad records. After collecting inputs, we use dict and append to the list. So we have expenses append right here, and that's the actual insert operation. Right after insert, we call insertion source in place expenses by amount. This is our own in-place insertion sort. There are 2 reasons why we use this way. The first one is that the list is typically nearly sorted between inserts, so insertion source is more effective this way. And the second one is that It is simple to implement and explain for a mini project. We explicitly show algorithmic control over comparison and swaps.
Hello, my name is Sukikun Lawarun. I will be explaining the deleting and expenses by index, which is the function delete then choose right over here. So what is this function for? It's a function that let the user remove one expenses from the list by typing its index. It will show the user the list of the expenses, then let the user choose the index what to delete, then it will show the updated list in the end. So how does it work? First, it will show the delete screen. So first it would clear out the console, um, the option that user can choose, it will clear out. Then it will print out delete expenses, which use the pretty function to show the list. So it will help the user to see the right index they want to delete before typing. Next is if there are no expenses, no list, it will print out a message. Press enter to return to the menu. This avoid error like index out of range. And next, it would read the user choice like index to delete from 0 to n, which is the length of the expenses, or type B to go back to the main menu. If the user type B, Q, and X, it would bring them back to the main menu. And if it's not a digit, it like maybe the user type the word hello, it would show invalid input and then it will loop again. So next, after the user enter the index, which is a number, it would convert to int and check if it's greater or equal to 0 but still less than the length of the expenses. And if it do, it will start this function, which is to remove the index that user choose to delete that entry. Then it will call insertion sort in place to keep the list tidy, and in the end it will be a clear screen and show the updated list of the after deleting the index right here, and show the list by using the pretty and expenses. And in the end, for the user to return to the main menu, the user would need to press enter to return to the main menu. Oh, this is another thing. If it's not if the index is not does not meet this condition, it will print out index out of range. And I would like to talk about the time complexity. So I will let the n be the number of the expenses. So the delete at index, the pop IDX right here, uh, it's a list like array. So removing item will shift element to fill the gap, and the worst case would be ON. So next is resorting with a insertion sort right here. So the best or typical case here would be close to O by N, and the worst case it could be would be a O N square, but it's unlikely to happen because it's our app is like deleting just one item scenario, so it's unlikely to happen. So for overall per deletion, it's roughly O by N.
Hello everyone, and my name is Piachai Vichapon, and today I'm going to be talking about the sorting in our expense tracking program. So I'm going to be talking about the algorithm behind it and what it does. So let's first understand why we have the sorting. So the sorting function is there so that the user can easily be able to analyze and understand the data more clearly. We can sort the data by the amount or the date. And we can also choose if we want it to be sorted by the ascending or descending order. Now let's just go see the real program. So here is our program, and for the main menu we can choose the sort by entering the number 3. After that, it will ask us if we want to sort by the date or by the amount. 1 will be the date and 2 will be the amount. For this time, let's just choose the date. And next, they will ask us if we want to sort by the ascending or descending order. 1 will be ascending and 2 will be descending order. Let's just choose descending order for now. Okay. So after we have done that, we will see that it has been sorted by the descending order. So here, here, and here. Yeah. So now let's go see the algorithm behind it. Okay. So the algorithm that we use is that we use insertion sort. So if you imagine insertion sort is like when you're playing a card game, you have a hand full of cards, right? You pick up another one, and then you see from left to right where the next card should be placed, and you place it there. That is exactly how insertion sort works. So let's go see the code now. So first is that we start with the index 1, so we keep the left side sorted. And then we have the nxt variable to represent the current element, and we have the j to compare with the elements before it. Next is this part where we will check if we want to sort by the date or by the amount. And for this part is where we compare the current element to the one before it. If the one before it is larger, we will put it one place forward, and we do the same until we find the correct place for it and place it there. And this is in opposite if it is descending. So now I want to talk about the time complexity of the insertion sort. So the time complexity of the insertion sort is O(n). And for the worst case or the average case of the insertion sort, it is O(n power of 2 or O(n squared). Since our list is currently pretty small, so I think it is effective to use the insertion sorts. But if we go to a longer or a larger list, I think it might be better to implement a faster algorithm like merge sort or quick sort, which have a time complexity of O log n, which is faster if we compare it on a larger scale of data.
Now, let me show you our search function. The goal is simple. Find the right expense fast. By date, category, item keyword, or exact amount. Technically, when I choose search in the menu, the program filters the in-memory list based on my input. For example, a date like 2025, 09, and 02, a category like food, a keyword such as a coffee, or an exact amount like 55 baht. Under the hood, it is a straightforward linear scan across the list to keep the logic predictable and easy to maintain. This design also avoids surprise for user. What your type is what you get. I pressed 4 search, choose 3 items, type a coffee. The app shows just the matching row and a count of results, so I instantly know how many records match. In short, search boosts speed, accuracy, and trust. You can verify or edit a record without scrolling through everything. Next is show total by categories. This feature group every expense by category and add up the amounts, so you can instantly see where your money actually goes through transport, study, and so on. Implementation wise, we traverse the list one aggregate into the category total map, then render a clean table in the same category order. Zero total category are hidden to keep the view focused. The quick demo, I press 5 from the menu and add the app prints a nicely format summary with one row per category and the sum at the right. This gives you a clear spending profile, perfect for budgeting decision and monthly reviews.